Go.
Okay, we have Unit 8, Electricity and Circuits. Okay, so indicators, light bulbs and compass deflections. Light bulbs and compass deflections. When a new object affects the indicators, we can learn if it is an insulator, conductor, or resistor. So a conductor permits the flow of energy, an insulator does not permit the flow of energy, and a resistor decreases the flow of energy.
So Ohm's law.
Here's the list.
Ohm's law. It states that the current in a circuit is directly proportional to the voltage impressed across the circuit and is inversely proportional to the resistance of the circuit. That's right there.
So these are the equations for Ohm's law. I equals V divided by R, V equals I times R, and R is V divided by R. And then represents the current through the conductors, which is measured in amps, or amperes. V is the voltage measured across the conductors, which is measured in volts. And R is the resistance of the conductor, which is measured in ohms.
So current. Current is electric current is the flow of electric charge. Electrons carry charge through a circuit because they are free to move throughout it. Current is directly proportional to voltage. In this case, if the voltage goes up in a circuit, the current increases as well. Current is inversely proportional to resistance. In this case, if the resistance is greater, then the current will decrease.
Voltage. To have a sustained current, you're required to have an electric pump to support the voltage differences, and this electric pump is a voltage source. Batteries and generators are voltage sources that supply energy to make charges move, and a chemical reaction in a battery releases electrical energy. This electrical energy is available at the terminals of the battery, and don't be fooled, electrons are everywhere in the circuit, not just at one end of the battery. And closing the loops and creating a continuous connecting path with a voltage source allows the electrons to start moving.
So resistance. The current also depends on the resistance of the conductor that is pushing it through. The resistance depends on the material of the conductor, such as the material it's made from, its length, and its width. Thick wires have less resistance than thin wires. Longer wires have more resistance than short wires. Resistance in the circuit decreases the electron's ability to move. As the conductor gets thicker, there is less resistance. So an example is students in a hallway. A wider corridor allows for easier flow.
So the conventional current is the direction that the current is moving, and the reversal of a compass when the battery orientation is reversed indicates this change in the direction of charge, but it doesn't provide any information about the actual direction it's moving. So, because there's no actual evidence, scientists assumed a direction for the motion, which is conventional, and the conventional current is that the charges circulating through the current leave the battery at the positive end and re-enter at the negative end. And here is a drawing showing, so it comes out the positive side and this end.
So electric charge. When ends of an electric conductor at different electrical potentials, a charge flows from one end to another. Charge flows if there is potential difference in voltage. If there's no different voltage, there's no charge. So to keep a flow of charge, you must keep one voltage higher than the other.
So here are some helpful information from the Class 1 summary exercise. So there's some of these statements. It says, indicate whether these following statements are true or false. And then, so the first one is charge moves out of each end of the battery into a loop, which is false. The compass needle deflection indicates the charge moves in only one circular direction, out at one end of the battery and in at the other. The second is light bulbs are non-directional devices, which is true. The brightness is the same even if you turn the bulb around. C, the battery determines the direction of flow of charge in a circuit, which is true. If the wires connected to the battery are reversed, the compass needle deflection will also be reversed. And D, a compass can be used to determine the exact direction that charge flows in a circuit, which is false. The compass can be used to determine relative direction, but not absolute direction. And finally, metal substances are generally conductors.
True.
And we learned that when we did the CAS packet.
So here are some more summary exercises and different questions you can get. So how is a light bulb like a resistor? Adding a light bulb in a series circuit adds resistance to the circuit just as adding a resistor does. Number 2, which has the thickest filament, a high resistance bulb or a low resistance bulb? A low resistance bulb has a thicker filament. Number 3, what are 2 types of observations that can be used to indicate flow rate? And that's bulb brightness and compass deflection. And number 4, when more bulbs are added to a circuit, is there always more total resistance as the result explained? No, if more bulbs are added in series, the total resistance increases. If more bulbs are added in parallel, there's less total resistance. And number 5, what experiments suggest that wires have essentially zero resistance? Number 1 is adding more wires in series with a bulb does not change the brightness of the bulb. The wire must have little or no resistance. And shorting out a bulb causes the second bulb in series to become much brighter, so it has less resistance.
What is a circuit? It is a closed loop that containing a voltage source, usually a battery, and a series of wires that allows electrons to travel through them, providing a current. Sometimes the purpose of a circuit is to power something, such as a light bulb that is a resistor.
It looks like. So how do circuits make light bulbs light? So a light bulb is attached to a metal socket that has a metal clip on both of its sides. The metal clips are attached to alligator wires that attach it to the rest of the circuit. The light bulb provides resistance, so when the electrons are pushed through the thin filament, they light up.
So there's 2 types of light bulbs. They're the ones that we did experiments with, which are long bulbs, which have a very thin filament, which means more resistance, and round bulbs have a thicker filament, which means less resistance. So think about like the hallway again, with like a wider corridor, makes it like easier, so there's less resistance.
So there are two ways multiple light bulbs can be arranged in a circuit. The first one is series, where the bulbs are one right after the other in the circuit. And the second one is parallel, where the bulbs are parallel to each other. So there are those are the 2 different ways to arrange them.
This is how to draw the circuit, or a simple circuit.
Yeah, so it has like a battery and the light bulbs and regular resistance with bulbs on the bulbs.
REQ is the equivalent resistance. So when you aren't given all of the parts of a circuit, the voltage, current, and resistance of each resistor, and you define the amounts of these, it's hard to do so with so many resistors. So you need to simplify the resistance of the bulbs by adding their resistances together for the total REQ.
REQ in a series circuit, so to get the REQ in the circuit, you add like the resistances of each of the bulbs. So you can call the bulbs R1, R2, R3, as many as you have, and just add them together.
So then REQ in parallel circuits is a little bit more complicated. So it's 1 over REQ equals 1 over R1 plus 1 over R2, or however many you have. And the first step is to put the resistance of each light bulb as a fraction in the denominator with the numerator as 1. Then find the common denominator of both fractions so that you can combine them. And if you notice, the formula is equal to 1 over REQ, so you have to get it to be equal to REQ. So you need to flip like the reciprocal of the fractions that you just added as well. And once you flip it, divide as it suggests, and you will have your total REQ.
So we find the voltage and current. So while simplifying a circuit, you work backwards using the resistance you already know of like the branches that are in the circuit, and using the rules of voltage and current in parallel and series circuits. You do this to find the voltage and current.
So voltage and parts of the current in a series circuit.